Today we're looking at trigonometry. So we're gonna solve this problem here. Okay, so let's look at the problem. Ship A leaves port and sails at a bearing of north 29 degrees 10 minutes east at a speed of 21 knots. Ship B leaves the same port at the same time as ship A at a bearing of south 60 degrees 50 minutes east at a speed of 15 knots. Find the distance between the ships after 3 hours. So let's draw the north, south, east line for this one. Okay, so that's the first thing you have to do. Similar to the XY coordinate plane, I'm thinking north, south, west, and east. So let's look at ship A. It leaves at a bearing of 29 degrees north, 29 degrees 10 minutes east. So somewhere around here. And this is 29 degrees 10 minutes. Okay, 21 knots. So I'm gonna call this A right here. Ship A, 21 knots. And ship B leaves the same port at the same time as ship A at a bearing of south 60 degrees 50 minutes at a speed of 15 knots. So I'm gonna make this longer here. And this one's gonna be this way. So about there. And this is gonna be 60 degrees 50 minutes. Okay, so that's triangle there. And they said after 3 hours, what is the distance between the ships? So this is A, this is B. Okay. And when we find this, we know it's a right triangle because these angles here, 29 degrees 10 minutes, 60 degrees 50 minutes. You're gonna add it up. This is 89 degrees 60 minutes. It's equivalent to 90 degrees. Notice this here, there are supplementary angles, so that means this is 90 degrees. Okay, so let's look at distance A first. So I'm gonna put A right here. Remember now, knots, it's a term you use in for speed for boats and ships, and it's equal to nautical miles per hour. Okay, 1 nautical mile is equal to around 1.1508 miles. So kind of little over a mile. Okay, so anyway, we have the work set up here for us. All we gotta do is find the distance. So from algebra, you're never gonna get away from this. Rate times time equals distance. Okay, so let's look at the rate in nautical miles. It's 21, A is 21 knots. So I'm gonna put it in terms of nautical miles per hour. Nautical miles per hour. Rate times time, we said it was after 3 hours. So this is gonna be 63 nautical miles. Okay, for B, okay, so we have 15 knots or 15 nautical miles per hour. And we times it by rate times time, 3 hours equals 45 nautical miles. Okay, so now we have the distances here. We put 63 nautical miles, 45. What stands out is right triangle, 2 sides, Pythagorean theorem. D squared equals to 63 squared plus 45 squared. D is equal to the square root of 63 squared plus 45 squared. and get a calculator here. Square root of 63 squared plus 45 squared. And it turns out to be that distance here is going to be 77.4209274. Or I'm going to say nearest tenth, 77.4 nautical miles apart. There you have it. Here's your trig problem here. Knots is the term they use for ships. It refers to speed, nautical miles per hour. 1 nautical mile is about 1.1508 miles.